Okay, in this video I'm going to show how to build what I call an under-counter dust isolation circuit for the router tables. And I did a video explaining this setup, and I talked about the dust collection, but it was one of my earlier videos, so I'm going to just go over it again and hopefully explain it a little bit better, and then actually do a demonstration building one for my router table over here, which does not have any dust collection underneath the table. So when I hook it up, I have a fence that has dust collection over the table, but when I'm doing a large production of cutting boards, for example, there's a lot of dust that falls and collects below the table, and some of that is fine particulate dust as well. And that is more of a problem and a concern, that it does create airborne dust. Most of the dust is picked up above the router bit table, but there is some dust that goes underneath, and it will accumulate over time in larger production runs. So I've had some problems with that before. It's just been kind of a nuisance to sweep up under there, and it would be better to have dust collection under there. And typically you would see a router table that's boxed in, enclosed, and you hook up a port and then have a return airflow, and that's what you use to keep chips and stuff from building up there. But that is not as effective, especially in production. I found that by containing all the dust, by making an enclosure around just the housing that isolates the dust from the motor. Otherwise you have dust recirculating through the motor, which I think would be bad over long-term use. But this is very effective and proven to work, so I just want to build another one here and have that be functional. I already have the dust port underneath where I can hook it up. But I'm going to do it a little bit differently. This contraption is a little bit more complicated than it really needs to be. I have two routers on one machine and two loops, which are then connected in parallel over here. And that's just a fancy way to do that. So both of these move laterally, and that all adjusts. And this is the one that gets all the dust above the table. So I have other videos for this machine. I'm going to do a small test run just to show how it works again. But I'm going to do the same thing here, but without all the PVC fittings. I'm just going to use flexible pipe, which should work just as well. So I ran this machine for about 2 hours today and made about 800 parts. And if I did not have dust collection, that would make a phenomenal amount of fine dust, which I did before. When I first got this thing set up, I didn't really get the dust collection right, and it produced quite a bit of dust, and it was a major problem. The under-counter dust isolation circuit was invented out of necessity to contain all of that fine dust that routers produce, and have that work in continuous use. So if you're just doing a little bit of router work at a time, you're not going to really create a major hazard inside your shop. But of all the woodworking machines that are commonly used, routers, I'd say, will definitely put out a lot of dust. That and the table saw, if you don't have that contained above the blade. I just ate a lot of watermelon, so I'm a little out of breath. Whew. This is probably the simplest router table that you can possibly get. I used 3 pieces of Corian, 1/2 inch thick, the solid surface kitchen material. I thought it would work well as a tool surface for this, and it does work okay, but it's not as slippery as I had hoped it would be, but it does work really very well. and I can screw things right into it. It's not as difficult as cast iron or other metals, but aluminum probably would be better if I was going to do it over. So I'm going to do a quick demo with my router set up here just to show how that works again. Then I'm going to make another circuit for this router table, which I've been meaning to do for quite some time. So I'll be happy to get that done. Dust collection is important, and I have to say that this innovation for router tables has worked very well for me and is definitely worth the time to build. So safety is priority number one, and fine dust containment and maintaining the life of your tool are both important things. Okay, so this is what the underside of my mysterious router table looks like. I have a barrel nut inside there. And so what I have to do is build a not very big enclosure here just to put these things on. So these are going to be the 4-inch openings. I'm going to have one here and another one kind of angled a little bit. And so I have to get some 1/4 inch or 1/8 inch plywood to conform to this curve here. And the only thing I have to be really careful about is to allow enough room to allow the adjustability for this T-nut here. So I don't actually have a whole lot of room to work with. So I just kind of have to eyeball some measurements here and just cut up some scrap wood. So like I said, the most important thing to watch out for is just making sure that you have enough clearance to get to the locking mechanism. On some models of routers, the locking mechanism just isn't in the right location to make this work. So this is a much simpler version of what I made before. On my fancy router table, I notched the PVC so this acts as a baffle right here, so dust doesn't build up in the corners. I don't know, I just kind of wanted it to work as good as possible because I wasn't sure how good it was going to work. So I over-engineered it a little bit, but I'm really not worried about dust building up in here because it's still going to be contained in there, and I'm not really worried about it clogging because there is a lot of flow of air from the motor and from the dust collector. So, what do you think, Joe? Do you approve? I think Joe approves. Joe's a happy, dust-free cat. Some woodshop cats have it rough. So I've got some gaps in there I didn't see before. So I'm just going to get in there with some foam. Okay, my dust isolator is complete. It took me a while to figure out how I was going to make these connections, but I chose a simple route. I had an extra connection down here that I wasn't using, and I thought I would make use of that, but I ended up removing it, that whole contraption there, and that opened up more space here, which actually is going to make things easier, because I have to get access to the table saw door that swings open, so I have to get it to open a little bit so I can clear it out. And there's one drawback to my router modification, and that is that I have to take this motor all the way out to be able to change the bit, because I no longer have access to underneath the table because I have this block of wood here, and you know, it's a pain in the neck to change the bit either way. I almost think it might be easier just to take the whole motor out, because I don't have a whole lot of room to get my fingers in there to, you know, I've had problems with it before. There's no easy way to do it. Really, the smart way to do it is to design the router so that, you know, it protrudes far enough so that you can change the bit above the table surface. And I believe there is one brand that does that. Wish I knew that before. But, you know, these Porter cable routers are pretty common. They've got good motors. They last a long time. And, you know, it's a very simple raise and lower mechanism. It doesn't have any fine adjustment, but I've really never felt the need to really get finicky. I know there's a lot of gadgets and gizmos for routers these days. There's also a collet extension for about 40 bucks. It gives you about an extra 2 or 3 inches up there so that you can change the bit above the tool surface. But I'll deal with that if it becomes more of a hassle. But for now, this is going to be a production router for, you know, doing more production use. I do need another router table. It kind of sucks just to have one. I used to have 2, actually. But this one is going to be for the production use, so that I have the dust collection ready, so that, you know, when I'm doing the dusty operations, I'll have that contained. Really, this router table is the only tool that I had left that was producing airborne dust on certain occasions. So I have a 3/4 inch straight bit, and I'm going to make some test cuts out of some scrap wood. Now normally this type of cut will be problematic, and I don't normally cut mortises or dados on the router table, and the setup time for routers is usually higher than the table saw, which is the preferred method. I usually keep the dado blade permanently on here because I do a lot of that type of joinery. But routers take longer to set up, and they generally make a big, huge mess. And for this type of cut, the dust collection hookup at the fence does virtually nothing, because the workpiece is, you know, concealing the cutter completely to, you know, this space underneath here. And so all the chips, hello Joe, so all the chips for this type of cut are forced to go underneath the table, and this is going to be a good test of the system to see how it can handle all of that sawdust. So this is my first test of my dust isolator. And so this is the hose that I'm going to hook up to this part here. And I should have a quick disconnect I'm getting a little tired of using that hose clamp. But I think it makes more sense to use this branch of the air system, because then I can have the router fence hooked up to that port under there, and that's a different branch. So that optimizes airflow at both ends. So well, Joe, it's time to make a lot of noise. So I'm going to do a test cut, test out the system. It's all done.